Hi, in this short movie I'll present a short paper injecting knowledge-based information into end-to-end joint entity and relation extraction and coreference resolution. Our research in the short paper confirms the positive influence of external knowledge sources on an end-to-end joint information extraction algorithm, and we will show that the information of two different sources proves beneficial. On one hand, we'll use entities trained on the hyperlinked text corpus of Wikipedia, which we refer to as Gabi text. On the other hand, we'll use entities trained on the structured tuples of Wikidata, which we refer to as Gabi graph. The research builds upon previous work of my co-author Zaporozhets, which is inspired by the dynamic span graph model shown at the left-hand side. It are the spans that we will use to append the external knowledge to. More concretely, here we see the span entering the KB module, where the algorithm looks up the text in a general dictionary, which returns the possible entity candidates. These possible candidates are then combined using a weighted average, resulting in the embedding that is concatenated to the text span. More concretely, in this short paper, we researched how the candidates can be combined and which unstructured source is most helpful. To answer the question to whether KB text or KB graph is most helpful, we show a selection of our results table. The metrics used are entity-centric and not on mention level, and as can be seen, both types of embeddings give an improvement, but the concatenation of both types gives the biggest improvement for the coreference resolution, named entity recognition, and relation extraction tasks. So this triggers the idea of them being complementary. To answer the second question on how to combine the entity candidates, we explored three configurations. One which uses the prior of the entire Wikipedia corpus as weights, another configuration that uses additive attention as unsupervised linking mechanism, and a third configuration which adds the prior of the Wikipedia corpus as an extra feature in the attention mechanism, which exploits both advantages. The figure on the right is here an example of where the prior wrongly links the text span Red Planet to the film, while the sentence, so the local context, clearly talks about the planet, so where attention prior can find the correct link. The results prove as well that the combination of attention and prior is the strongest. A last important insight is the positive influence of the entity embeddings on the prediction of the rare entity types in the NER task. This effect is clearly shown on this graph, where the x-axis represents the amount of times an entity type is seen in the training data, and the y-axis shows the improvement of the base in comparison to the baseline, where there's a performance increase of almost 14% in the bin containing entity types, seen less than 50 times in the train set. This was an overview of the results. If you have any questions, you can contact us. Thank you for your attention.